Hello my dear students, today I will be discussing about soil nailing and Gabion walls and reinforced earth. So let us discuss first about soil nailing. It is used to reinforce and strengthen existing ground. Installing closely spaced bars into a slope or excavation. You can see here these are the soil nails. Okay, it is an effective and economical method. Act as a retaining wall for excavation support. Applications: these are mainly used in landslide remediation, railway embankments, roadway widening under existing bridges, stabilizing of existing retaining walls, highway embankments and cuttings. You can see here this is for stabilization of highway cut slope. Okay, and stabilization of railroad. You can see here the soil nailing is done here, and also you can see here, here that is tunnel portals in steep slopes and also stabilization of steep slopes. Okay, so these are the some of the applications of soil nailing. There are different types of nails are used for soil nailing. The mainly used nails are drilled and grouted soil nail, driven soil nails, self-drilling soil nails. Okay, and materials used for soil nailing, that is steel reinforcements, grout mix, shotcreting or gunite. Okay, so this you can see here the reinforcement used in soil nailing. Okay, these are the here you can see here these are the reinforcement used in soil nailing, and these are the grout mixes. This is also used for soil nailing, and this is shotcreting, applying these grout materials. Machineries used are typical drilling equipment, grout mixing instrument. Shotcreting is done using a pipe and compressor. The procedure of soil nailing: excavate small cut, drill hole for nail, install and grout nail, place drainage strips, initial shotcrete layer and install bearing plates. Repeat process to final grade. Place final facing on permanent walls. These are the some of the steps involved in soil nailing. The advantages of soil nailing: shotcrete facing is less costly, grouting only once is required, saving time and labor. The technique is flexible, easily modified, less impact on nearby properties, can be used for strengthening of either natural slope or man-made cut slopes, allow excellent working space in front of the excavation phase, rapid and uses less construction materials, economical. And next let us discuss about gabions or gabion walls. You can see here gabions are wire mesh baskets compactly filled with stones, rocks and other hard materials, properly wired together for construction of erosion control structures and to stabilize steep slopes and prevent erosion. Gabion faced retaining walls can generally accommodate large lateral and vertical movement. Gabions are multi-celled, welded wire or rectangular wire mesh boxes which are then rock filled and used for construction of erosion control structures and to stabilize steep slopes. Material used are geogrid, wire mesh, rock, mixture of stone and rock waste, geotextile terum and nylon wires. Uses are road construction, river draining, weirs, control of flood waters, earth retaining structures, water recharge dams, soil erosion and bridge protection. Advantages of gabion walls are monolithically, easy to repair, cost effective and suitable for all types of soil conditions. Work is simple, fast. Work is not affected by climatic changes. Cost savings, eco-friendly and also reduces sound pollution and absorbs vibrations. Gabion structures can be built quickly and economically under all conditions and are especially suitable for stabilizing slopes in mountains regions and in regions with unfavorable soil characteristics. Areas of use of Gabion structures are mass gravity retaining walls, mechanically stabilized soil retaining walls, supplementary elements of buildings, garden architectural elements like benches, partition walls, etc., channel linings, river beds, culverts and bridge abutments, gully control, water velocity reducing structures. Next, let us discuss about reinforced earth. Reinforced earth is a composite material formed by the association of frictional soil and tension resistance elements in the form of sheets, strips or nets of metal, synthetic fabrics or fiber reinforced plastics. Reinforced earth is a combination of earth and linear reinforcing strips that are capable of bearing large tensile stresses. The reinforcement provided by these strips enable the mass to resist the tension in a way which the earth alone could not. The source of this resistance to tension is the internal friction of soil, because the stresses that are created within the mass are transferred from soil to the reinforcement strips by friction. Reinforced earth is also called as reinforced soil, generally used in retaining walls, embankments, quay walls, underground structures. Henry Vidal, a French engineer, demonstrated the concept of reinforced earth in 1966, and later on Dr. Jones, scientists, continued it. Main objective is to improve the engineering and mechanical properties of soil. Because of its technical superiority and economic advantages, reinforced earth has become a widely used in the construction of earth retaining structures. Components of reinforced earth: soil, skin and reinforcement. You can see here, this is a reinforced earth. Means soil is reinforced here. The arrangement of the components in reinforced earth structures: these are the facing elements, this is soil backfill, and this is the reinforcing elements. Soil for reinforced earth: it should be granular, cohesionless material, not too much silt or clay, having particle size not more than 125 mm. Not more than 10% of the particles shall pass 75 micron sieve, and the earth reinforcement coefficient of friction to be either higher than or equal to 0.4, and plasticity index is less than 6. The soil must have a moisture content suitable for compaction. Skin is the facing element of the reinforced soil wall. These elements keeps the reinforcement at a desired elevation in the reinforced soil wall and also protect the granular at the edge falling off. Made of either metal units or precast concrete panels. Reinforcing materials: the variety of materials can be used as reinforcing materials. For example, steel, concrete, glass fiber, wood, rubber, aluminium. These are all used as a reinforcing material. Reinforcement may take the form of strips, grids, anchors and sheet material, chains, planks, rope, vegetation and combination of these or other material forms. These are some of the applications of reinforced earth, where a bank is eroding and sliding onto a road near a building, etc. A reinforced soil structure can be a cost-effective solution. You can see here. Okay, these are the reinforced structure. And also, bridge abutments can be effectively constructed as a reinforced soil structure. Here, a reinforced soil bridge abutment. This is for reinforced soil retaining wall. Next one is for a reinforced soil box culvert or small bridge structures. You can see here. And also reinforced earth structure in railways here. Then reinforced soil wall, a vertical walled structure formed by increasing the stability of the backfill of the retaining wall with the installation of reinforcement materials such as geogrids and steel strips into the backfill. While designing a reinforcement soil wall, we need to consider external stability and internal stability. These are some of the modes of failures: external, that is base sliding, overturning and bearing capacity. Okay, bearing capacity because of excessive settlement. Here this you can see that is overturning, and this is the base sliding. Then internal failures are pull out, tensile overstress and internal sliding. Then facing failures are connection failure, column shear failure and toppling. So these are some of the modes of the failures. I hope all of you understood. Thank you.